Hello and welcome. In this video, we're going to be talking about mole conversions. And specifically, we're going to be talking about grams to moles and moles back to grams. So in talking about mole conversions, the first thing that we need to do is discuss what mole conversions actually are. And in chemistry, mole conversions are simply the mathematical between grams, moles, and particles of a substance. We can convert grams to moles, moles back to grams, moles to particles, particles back to moles, all the way to particles, and then particles all the way back to grams. This specific video is going to be the first in a series of 3, and we're going to focus simply on the grams to moles and moles back to grams type of conversion. So when we are looking at converting between grams and moles, we're going to need the molar mass of a compound. This was covered in another one of my videos. So if you haven't watched that video, please make sure that you go back and watch that so you know how to calculate molar mass. We will be looking at some examples, so you might be able to pick up on it from this video, but if not, go back and look at that previous video. When we are converting between moles and particles, however, that's when we're going to need Avogadro's number. And we talked about Avogadro's number in another previous video. If you haven't seen that video, again, please go back and take a look at it. So focusing directly on grams to moles and moles back to grams. When we are converting from grams to moles and using that molar mass, you can see from the slide that to convert grams to moles, we have to always use a conversion factor of 1 mole per the molar mass of that substance. The reason being is our starting amount is going to be given in terms of grams, and then our molar mass is always in grams per mole, but we're taking that ratio of grams to moles and inverting it so that we've got 1 mole per that molar mass in terms of grams. This way, the units on our starting amount will cancel out with the units on molar mass and in the conversion factor, and you're going to be left with an answer with the units of moles. Likewise, and when we're converting from moles back to grams, we're always going to use a conversion factor of molar mass per 1 mole. This way, our starting amount in terms of moles, we'd have 1 mole in the denominator, and the units of moles would cancel, leaving us with the units of grams. So let's go on and take a look at some examples. So in this first example, we're going to be converting 50 grams of sodium to moles of sodium. So we're looking at just an element. And as I always instruct my students, when we are looking at any type of word problem, always go through and diagram that word problem. So it asks me how many moles, so how many is a question, and it's referring to moles. So automatically I know that moles are what I'm solving for. And it says of Na, so here is a substance, are in 50.0 grams of that sodium. So that 50 grams is what I refer to as the starting amount. And anytime you're doing a mathematical process, you always have to have a starting amount. So look for the numerical value in the problem. And that's going to be the amount that's out in front of your conversion factor. So as I look at this problem, and I've got a starting amount in terms of grams, and I'm trying to calculate the number of moles, that tells me that I need this upper pathway on what we refer to as the mole roadmap. So when I go to work this problem, my 50.0 grams of sodium in my starting amount times a conversion factor. And again, that conversion factor tells me that I need 1 mole of my substance, in this case, which is sodium, per its molar mass. And this is where we'd go to the periodic table. And if we look up sodium on the periodic table, we'd find a mass of 22.99. And that would be grams of sodium. Now I can do the math. And whenever I've got a conversion factor, recall you're always going to multiply by what is in your numerator and divide by what's in your denominator. So when I look at this before I actually do any numerical values, I notice that the units of grams cancel, which means my final answer will indeed come out in terms of moles sodium, which is what I'm solving for. So this verifies that I have the problem set up correctly. Now I can do the numerical math. So I'm going to type into my calculator 50.0 times 1, which you really don't have to multiply by 1, and then divide that by 22.99. Hit enter, and I get a final answer of 2.174, but the 4 does not round the 7. So my final answer is 2.17 moles of sodium. And the reason why I round it to simply 2.17 is because my starting amount has 3 significant digits, which means my final answer needs 3 significant digits. So there is my calculation for moles of sodium. This should make sense on just a logical level, because if it takes approximately 23 grams of sodium for 1 mole, and I have 50 grams of sodium, then I should expect an answer that's going to be greater than 1. And that's what I get. And if I double 23, then I'm looking at 46. Well, if I start with 50 grams, and it would take 46 grams to get me 2 moles, then it means I should have an answer slightly more than 2. And indeed, we get that 2.17. So our answer makes logical sense as well. And this is what you should always do when you're working any type of these problems, is always look to see, does the final answer make logical sense? In addition to, do the units work out correctly? So that's the first example. Here's another example. 15 grams of sodium to moles of sodium. So again, I'm going to diagram this word problem. So how many, that's my question, and it refers to moles. So that's what I'm solving for, of sodium. So that's my starting amount, and it tells me 15 grams. So when I set this problem up, my 15.0 grams of sodium out in front, and then my conversion factor. And again, because I'm starting with grams and converting to moles, I'm going to take this upper road of 1 mole per the molar mass. So on top, or in my numerator, 1 mole of sodium per the molar mass of sodium, which again is going to be that 22.99 grams of sodium that we look up from the periodic table. And in this case, again, after I verify that units cancel and that my final answer is indeed going to come out with units of moles sodium, I can do a little bit of logic. If it takes approximately 23 grams to have 1 mole of sodium, and I only start with 15, then I don't have enough sodium in my starting amount to even give me 1 mole of sodium. So I'm going to expect an answer that is a decimal, that is less than 1. So now I can do the math. 15.0, again, we would multiply by our numerator, divide by the denominator. So times 1 and then divide by 22.99. I hit enter, and I get a value of 0.6524. The 4 doesn't round the 2, so this becomes my final answer. And again, because my starting amount had 3 significant digits, my final answer needs 3 significant digits. So our logic was correct. 15 grams isn't enough to give me 1 mole, so I get a value less than 1. Want to mention something else very quickly. Please make sure that you always put that 0 out in front of the decimal. For teachers, if all you do is this, it's very easy for that decimal to get lost, and then you may end up getting the answer marked incorrectly. So always make sure that you put that 0 in front of that decimal. So this is 2 examples that I've done now where we're looking at just an element. Now let's look at a compound. And it still worked the exact same way, just that now we're going to need the molar mass of HCl, a compound, rather than the gram atomic mass of just an element. So in this problem, again, diagram, how many, my question is moles, are in 35 grams, my starting amount, of my substance. So I'm starting with grams going to moles. My starting amount is that 35.0 grams now of HCl. And then my conversion factor, where I'm still going to be following the upper road and using the conversion factor of 1 mole. In this case, it will be of the compound HCl. And then I need that molar mass. So to calculate molar mass, I have hydrogen, and I have chlorine. I have 1 hydrogen, 1 chlorine. And from the periodic table, hydrogen has a mass of 1.01. Chlorine has a gram atomic mass of 35.45. So 1 times 1.01 is 1.01. 35.45 times 1 is 35.45. And then I would add those two values up. So 1.01 plus the 35.45. And I get a mass of 36.46 grams. And remember, anytime we see grams, that is per mole. And this is our conversion factor. I haven't shown this in the previous 2 problems because we're simply looking up the mass of an element. But when you're doing a compound, the same logic works, but you can see a little bit better how that 36.4 grams per 1 mole becomes my conversion factor. All we've done is invert it. So 1 mole of HCl per the 36.46 grams of HCl. Verify that my units cancel out properly. So grams cancel, and that is going to give me moles of HCl. And then I can do my math, multiply by my numerator, divide by the denominator, and notice if it takes 36 grams to get me 1 mole and I only have 35, I'm again going to expect an answer that is slightly less than 1. So 35.0 divided by 36.46, and I get a final answer of 0.9599. So the 9 ends up rounding, and I get 960 moles of HCl. And again, 3 significant digits because my starting amount had 3 significant digits. So this is how we do this when we're dealing with a compound, grams to moles. It's the exact same as the logic when we are going grams to moles with just an element. So no real change other than having to calculate that molar mass of the compound rather than just looking up a mass from the periodic table. So now let's do the reverse. How many grams of HCl are in 2.50 moles of HCl? So again, I'm going to diagram my question. How many grams of HCl are in the starting amount, 2.50 moles HCl? So here's my starting amount. So if I'm starting at moles and trying to find grams, now I'm going to take the bottom road. I'm still going to have that starting amount of 2.50 moles of my substance HCl times the conversion factor. But now in that conversion factor, I need molar mass on top. And it's the same molar mass that we calculated in the previous problem. So that 36.46 grams of HCl per 1 mole of HCl. I can verify that units cancel. Moles HCl cancel. That is going to leave me with the final answer in terms of grams. So I know I've set my problem up correctly. And then I can do the math. 25 times 36.46. I hit enter and I get 911.5. But I need 3 significant digits. So this is one of those special rounding rules. First, second, third significant digit is followed by a 5, but because that 5 is followed by nothing, I look back at the last significant digit, and because it's odd, that gets rounded up. So I'd end up with a final answer of 912 grams of HCl. So throw a little rounding rules in there for you as well. Let's look at another one. 1.25 moles of NaCl to grams of NaCl. Again, as always, we're going to diagram that sentence. How many is the question, refers to grams, of NaCl are in 1.25 moles of NaCl. So the 1.25 is my starting amount. If you would like to work this one on your own, feel free to pause the video, work it out, and then unpause and verify your work. So I'm starting out with moles. So 1.25 moles of NaCl times the conversion factor. And because I'm going moles to grams, again, I'm going to use the bottom arrow, the molar mass of NaCl per 1 mole. So I need the molar mass of sodium chloride. So I have 1 sodium, 1 chlorine. Sodium is 22.99 from the periodic table. I'm kind of jumping ahead. I've only got 1 sodium, and it has a mass of 22.99. I have 1 chlorine from the periodic table. It has a mass of 35.45. I would multiply each one of those values by 1, which is why I didn't initially write the 1. And then we'd add them up. So 22.99 plus 35.45, and I get a mass of 58.44 grams. Again, because it's a molar mass, that'd be per 1 mole. And as I showed you in a previous example, that's where our conversion factor is coming from. And we get to leave it as is, 58.44 grams of sodium chloride per every 1 mole of sodium chloride. This way, our units of moles cancel. That would leave us with units of grams sodium chloride, which is what the question is asking for. And then I can do the math. Multiply by the numerator, divide by the denominator. So 1.25 times 58.44, divide by 1, and I get an answer of 73.05, or to 3 significant digits, 73.1 would be our final answer, grams NaCl. So, hopefully all of that made sense to you. If not, please leave me your questions in the comment section, and I'll be sure to answer as soon as possible. Also, don't forget to sign up and subscribe to this channel so you don't miss out whenever I upload new content. Additionally, if you have any suggestions for a future video, please let me know, and I'll do my best to get that video made for you. As always, I hope this has been helpful. Take care. Thanks.